Hi folks, my name's Andy Sinclair and I'm a flight instructor working in the PPL ground studies team at Bristol Ground School. This short video is an introduction to the flight computer. This little device needs no power source, has a variety of very useful functions, but is mostly seen as the nemesis of the PPL student pilot. Let's see if we can dispel some of that. It comes in a variety of names, it has a variety of names, for example, CRP1, ARC1. In the US, there is a larger variant called the E6B, which tends to be metal. And it does have a larger sibling, the CRP5. There's the CRP1 alongside the CRP5. I suspect that different names are more related to the manufacturer, the different manufacturers, as opposed to anything else. The common name for this device, in the UK at least, is the Whiz Wheel. There are no discernible differences in functionality between the CRP1 and the ARC1, but the CRP5 and the E6B, the larger siblings, this is the CRP5, are different from their smaller sibling. Insofar as they will permit calculations related to faster airspeeds, including Mach numbers, both on the circular slide rule side and on the triangular velocity side, which is also sometimes referred to as the wind scale side. So again, here's a CRP1. Let's get them the right way around for you. There we are. CRP1 in my left hand and CRP5 in my right hand. If you intend to continue your studies post PPL to gain a professional flight crew license, for example, a commercial pilot license, a transport pilot license, or an instrument rating, I strongly suggest you purchase the bigger sibling, the CRP5, as this will serve you all the way from ab initio to the right-hand side, or right-hand seat rather, of your chosen airline. Whichever Whiz Wheel you choose, it will have two sides. It has a circular slide rule side, and it has a triangular of velocities or wind scale side. On the circular slide rule side, that we'll look at in more detail today, a couple of points. It has a rotating inner scale rather. There you can see the rotating inner scale. It has a fixed outer scale. It has an index mark. Let's move that out of the way for a minute. It has an index mark which is there, top there, and it also has a cursor. As you can see, I'm moving the cursor now. In its simplest form, the Whiz Wheel can be used to solve ratio problems. A over B equals C over what? Of course, that can be modified to solve multiplication and division problems. However, when using the circular slide rule side, you need to be aware of the rough scale of your answer. For example, if you want to decide to divide 460 by 18, you would rotate 18 on the inner scale to align with 46 on the outer scale. Then reading the answer off the outer scale aligned with 10 on the inner scale. It gives you 25.6. Now, clearly 46 divided by 18 is not 25.6. However, 460 divided by 18 is approximately. 46 divided by 18 is 2.56. And 46 divided by 1.8 is 25.6, and so on. As you can see, it's important to know the scale of your answer, at least in terms of powers of 10 decades. This rather begs the question, why on earth would I use this device to make a very simple calculation like division? I've got a digital calculator. Well, that's a good point. However, doing so gets you familiar with the device. And it means that you get into practice so that when you want to calculate, for example, true airspeed from indicated airspeed at a given altitude, the mathematical solution to that, if you look at the maths of it, is true airspeed is equal to indicated airspeed divided by the square root of the ratio of the air density to the ISA service level air density. Okay, so that's kind of a little bit more complicated. And this is where the slide rule comes into its own. So let's say you're trying to calculate your true airspeed for an indicated airspeed of 95 knots, KIAS, 95 knots indicated airspeed, at a pressure altitude of 3,000 feet, with a calibrated outside air temperature, COAT, of plus 15 degrees C, which at 3,000 feet is ISA plus 6 degrees centigrade. Sure, you can do the square root dance, right? That probably will give you a good answer, no doubt. But if you take the circular slidable side of the whiz wheel, you have on there, I'm not sure you can see it here, you have on there an airspeed window. This one is here. Now, in the airspeed window, if you align 3,000 with plus 1.5, then read off the number on the fixed outer scale with which is aligned with 95, you'll see that the answer is 100.5 knots true airspeed. So I did a little experiment this morning, and using the whiz wheel, that calculation took me about 20 seconds. Using the equation, the arithmetical method, it took me around 15 minutes, and I got it wrong. So there's an important time advantage, very useful in an exam when calculating under exam conditions. However, you may say, well, you know, hold on a minute, I know the 2% rule of thumb. That is, the true airspeed is 2% higher per 1,000 feet than the indicated airspeed. Okay, so 2% of 95 is around 1.9. Times that by 3, you get about 5.7. Add that to 95, you get 100.7. So we got 100.5 using the whiz wheel. We got 100.7 on the 2% rule of thumb method. Okay, good enough for military work, as they say, good enough for operations in the air, sure, but that's okay as long as you don't get an examiner that's provided you 4 answers which are 100.5, 100.6, 100.7, and 100.8. For that level of accuracy, the 2% method won't help you, the whiz wheel will. Really, the last thing I want to lobby, to advocate for the whiz wheel is to say that the circular slide rule side, as alongside doing reasonably straightforward indicated airspeed to true airspeed calculations, the whiz will always help you with speed, distance, and time calculations. It can help with temperature rise scale calculations, and all manner of distance, speed, volume, temperature, ground speed, fuel consumption, mass and volume, volume to mass, and vice versa calculations you may come across in your PPL exams. Now, if you are still not convinced that a more modern digital tool would not be better for you, then my advice would be double check with your National Aviation Authority, French DGAC, for example, or the German LBA, or the Spanish AESA, just to make sure you are permitted to use those in exams. At least in the UK, you are not. You would only be permitted to use a certain design of calculator and also the whiz wheel. So to be a competent whiz wheel user takes practice, I'll concede that. There are a number of more detailed explanatory lessons at the end of the Bristol Ground School PPL navigation course to assist you as well. What I haven't done today is I haven't looked at the other side. That's the triangular velocities or wind scale side. Next time, the next short video, I'll take a look at the other side of this whiz wheel and we'll address the question, which is better, wind up or wind down? Cheerio for now. Bye.